Well, hello. The purpose of this video is to demonstrate how to work on the concept builder component edition. This is an assignment we currently have. Um, this is the wizard level, which should be the most difficult type questions you would see on this. So you'll start on more simple ones, but I would like to show the most difficult one and work through how to do one of these. One thing to note is this scale, 1 square equals 10 kilometers. And then it's asking some letters here and there. So what this is doing is this is saying what is each of these letters is a vector. What is vector D plus vector F plus D plus C plus B? What is the resultant vector of those? And the easiest way to do this, and that's what this is trying to walk you through, is to just add up their x and y components. So we start with vector F. On the x-axis, its x component, it's going down 3. So that would be negative 3 squares, which would be negative 30. One annoying thing about this, you have to put the negative afterwards. On the F vector, I'm sorry, I just said the x-axis. They're actually both negative 30, but this direction here would be on the y-axis, negative 30. And then on the x-axis, this way would be negative 30 because this vector is going over this way 1, 2, 3 blocks. Each block is 10, so 1, 2, 1, 2, 3. So that would be negative 30 on the x, and then the same on the y. I apologize for saying that backwards a second ago. If we go over here to D, D is starting here and it's going up 1, 2, 3. This is the y-axis. So on the y, it would be, in this case, it's going to be positive 30. On the x-axis, it's starting here and it's going the negative direction 1 square. So that's going to be negative 10. C is going in the, starting here, it's going on the x-axis in the positive direction 1 square, which would be 10. So the x-axis would be 10. And it's going to be going in the negative direction on the y-axis, so that would be negative 20. And then finally, B is going on the x-axis, positive 2 blocks, which is 20. And then it is not changing, staying on the x-axis. It has 0 change on the y-axis, and so then this one would be 0. Now the resultant vector is the sum of these. So if you take negative 30 plus negative 10 plus 10 plus 20, you're going to end up with negative 10. And if you take negative 30 plus negative 20 plus 0, you're going to end up with negative 20. I always hit that wrong. And we can check this. All right. Now the next thing it asks for is to show a thumbnail that shows what this would look like. So what it's saying is if we have negative 10 on the x and negative 20 on the y, which one of these resultant vectors, all labeled r, the red is the resultant, would reflect the x and y components of negative 10x and negative 20y, which are the black things here. So we're looking for an x component that goes down. So here the x component goes up. No, I'm so sorry. An x component that goes down by 10, that's down here. This x component is going in the positive direction, no. X component 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 negative direction, yes. It could be this one. Let's check out and see what's happening on the y component. Here we have a negative direction on the y component. That would in fact match that. So this would be a strong contender. Here's another one, negative in the x, negative in the y. And then these two do not follow those conventions. So our only two options are here and here. How would we know which is which? Well, we know that the x component is half the size of the y component. So we're looking for something that changes less on the x-axis than on the y-axis. So this one would not be correct. This is going to be the correct one because you can see that x component, negative 10, would compare graphically with a negative 20 here. So let's pick it and see what happens. All right, now for calculating the magnitude and direction. So here we're going to do a little bit of trigonometry, as we've talked about in the past. I'm going to try to take a screenshot here and go so I can sketch on this. Let's see if this works. Go to the good old snipping tool, and hopefully this will work. And so what we're really trying to do is we have here a triangle that would look like this. I apologize for this being kind of crooked, but this is the best I can do right now. So here we have a triangle. Our resultant on the x-axis is 10. This is 10 here. You don't have to follow the negative and positives. You can. It can sometimes help, but since you already see this arrow here, I think it's simplest just to go with just putting these numbers here and just looking at a right triangle here. So this is 10 and then this is 20. Now, Now this is a right triangle. And then over here on this side, this is your resultant. And that's going to be your magnitude. Now the easiest way to solve this is a right triangle is to use Pythagoras theorem, where a squared plus b squared equals c squared. So you're going to end up with, and I'm going to pause this if I can. Okay, so I have put this in. Give me a second. We'll get back over there. Oops, wrong document. So as you can see here, if we put in 20 squared plus 10 squared, that's equal to r squared, and we can solve for it. This is just Pythagoras theorem. We'll find that our missing side here, the side is in fact 2236. So 22.36. So we can go back over here to our This is Classroom, and we can try 22.36. This would be my number. And we can check it. It's going to come back and say that the angle is for sure wrong, but we can at least check this. Your direction answer is incorrect, but this is correct, 22.36 kilometers. So the direction, one thing to note here is this CCW. This is off of assuming 0 is on the x-axis in the positive direction. I'll show you that in a second. 22, 36, 10, and 20. So let's discuss how we would solve that. And the first thing I'm going to do is we'll try to get so we can sketch that again. So if we have here a triangle, one side is 20, one side is 10, and then one side, as we discussed, is 2236. So let's label those. Hopefully you can fast forward through some of this. This is, of course, 20, and this is 10. Now, it's important to note when we're doing this that the arrow was, in fact, going this way, so the tail was here, and the tip was down here, and that is relevant, and that's ultimately what the signs, negative 20 and negative 10, tell you, is it's going down and to the left. Would be in the negative quadrant. Well, what they're really asking for is in terms of what is that angle, and this is the way it's commonly described. They're really saying, well, what is that angle counterclockwise, where this is 0 degrees way over here? This would be 0 over here. And then going around this way, what is this angle right there? The easiest way to do that is to solve this angle. right here of this right. Of course, this is a right triangle. As I've said before, we've got to be able to solve triangles. You've got to solve for this unknown angle. Solve for this unknown angle right here. And then since we would know that the total, maybe all the way around here, you should know, hopefully, all the way around here would be 270 degrees. That's 270 degrees. You would just take 270 degrees minus whatever you solve that angle to be. I'm going to show how to solve that angle now, but if you understand how to do, obviously, solve a triangle using trig functions, you wouldn't need to watch the rest of this video. It's just as simple as 270 degrees minus what that angle is. It's possible on these that this